All right. Oh. So anybody have any questions from homework?
I have a question I didn't see on the syllabus. Where would we look for our grades throughout the semester?
What I do with grades is anytime you want to, you can come to my office and I can show you what it is. I don't do micro grade or anything else. I think you might be able to tell I'm not really big on those kind of things because they're not the most secure. I don't think so. But what I always do is after test 2, and then after every test thereafter, I give you a printout sheet of your grades, and I tell you actually what you're going to need to average on everything left to pass, so you have a feel for where you are and what you need to do. But at any moment in the class, you can just ask me, come with me to the office, and I can show you in the spreadsheet where you are. And trust me, you always at some point want to sit down. On the day of the final exam, I'll actually have my spreadsheet in class. Because you want to put eyes on what I actually have in the computer. Because I'm human. 86 might become 68 accidentally, and that'll completely throw you off. So no matter who your teacher is, you want to make sure they got everything correct in there so you're not messed up. Cool? Okay. Yes, sir.
In terms of homework, now I don't have the book. I've already actually sort of, went to the Amazon.com, but it'll take a few days to arrive. So if we can't actually turn it in on Tuesday, will that be a problem?
Well, what do you guys think? Anybody know the answer to that question?
Yes, that was a problem, but I haven't.
No. I'm not trying to make you feel bad. Don't worry. Everybody telling me stuff. No. When is the time that I'll consider it late? After the test. You always have until the day of the test.
Okay.
Because I know life happens. Especially in the beginning of the semester, you're waiting for your book to come. You go to the library, they're all checked out. You go to Math Study Center, they're all being used. You're like, ah! So you got time. Now you want to get a hold of it. You can make copies of the one in the library. You can actually check it out and take it home. You can get the one in the Math Study Center. You can come to me in my office. I can print you out the homework so you can at least work on that. You don't want to get behind, but you always have until the day of the test. So you got a little bit of time there.
Thank you.
Sure. Yes, sir.
So the test will be on the February 17th, the first test?
Yeah, you know better than me. You actually have your schedule. I gave all mine away. I forgot.
18th.
18th? Okay. Cool. So you have until the 18th of February.
Okay.
Do not, obviously, I don't have to say this, don't be a February 17th person going, okay, section 1-1. That's it. I shouldn't have to say that. That's a really bad idea, right? And somebody told me that the sooner you get me some homework, the sooner you get feedback. And if you give me homework before the review day, you actually get a decent amount of feedback from me. So I want those to become notes. And like I said, I don't like online homework because then I don't see people's reasoning, and I hate that. So a lot of my colleagues are going and making everything online, which would make my life a lot easier. I wouldn't have to grade anything. It would be awesome. I would wonder what I'm getting paid for, but I hate the fact that I wouldn't be able to see how you approach problems.
Do you
Yeah.
set a note taker?
Say again?
A note taker? Taker?
Uh,
Note taker. Do you set a note taker?
If you have somebody, yes. If you want to, you could talk to somebody yourself, or you can have DSPS work it out with somebody if that's something that they want to. They have special paper that they could use. So, yeah, if somebody wants to take notes for you, or if you can set something up through DSPS, yeah. Okay. Anything else? Yeah.
Yeah. Okay.
Page
87. It
Oh my-
says 2 through 80 even. So I just do the even ones, right?
Exactly. Yeah. Do
And
2,
on
4,
page
6, 8.
71, It says 3 to 81. E30. 88. What's that again?
What the hell's E30 mean? Every third one, not every third odd. Be careful. Don't be optimistic. That'll make it fly by. You do. Yes. Don't do that. Do every third one. So 3, 6, 9, 12.
What's that 88?
Okay. How we doing? Good stuff. We'll get those things out of the way now, so everybody understands what the hell they're doing. So how about any questions on math? Yes?
The whole chapter 1.
All right. So like I said, you can come see me in my office, or we can talk about that. You got a tutor set up. That's a good thing.
Sorry.
Yeah, that's all right. In class, I try to go decently slow so everybody's caught up, and if you're ahead of us, that's fine. Not a damn thing being wrong ahead of us. Otherwise, that's why I have office hours set up, to supplement what I can do in the classroom. Yeah, okay. So if you're getting behind and you're asking questions, and then I say, just see me in my office, don't take that wrong, just see me in my office. Not a big deal. We can work on it together. Cool. Okay. So if there's no questions, yes?
I did have one
All right.
question on number 88.
Is that the one about the average? Page 90? Is that out of the chapter 1 review?
No.
Which page? Maybe section 8, 1.7?
Yeah, it is.
Is that the one about finding the area?
I believe so, if I'm not mistaken.
Okay. So I'll tell you this. We haven't quite made it up to 1.7, 1.8. And on the homework sheet, I've got specific problems from section 1.7 and section 1.8. Because those two sections are sections where a majority of us might actually have a lot more trouble. That's where they define exponents and order operations. So we're going to cover that tonight. That very first homework assignment actually only goes from section 1.1 up to 1.6. So it stops at number 88. That only goes up to section 1.6. You guys with me? And then I have specific problems from 1.7 and specific problems from 1.8. So we'll get into 1.7 and 1.8 tonight, and then I'll make sure that I answer that question, or at least one like it, so you can do that one. Yeah.
Back to number 88, and find the average of 4. Basically,
Oh, so that's back in the review? Okay. Yeah, how do you find the average of, in this case, 4 numbers?
the way I did it, I had all 4 and divided by 4.
I love it. So to find the average of any set of numbers, you add them all up and divide by how many there are. I love it. I love it. I don't want to mess with that too much, but so if I had 80, 85, 92, how would I find the average? Yeah, so you add them all up. Okay, put the first letter up there. Add them all up, divided by how many there are. So in this case, that would be 80 plus 85 plus 92 divided by 3.
Where is 1.6? I see 1.5 on page 29, very close to 1.7.
Oh, 1.6 is up there on page 90?
Yeah, I got it.
Yeah.
Okay. That's the end of the first one, right?
Yeah, it goes up through where it says translating, up to number 88. Yeah. And then, can anybody help me out with that?
Like 85, something.
Let's see, what's 80 plus 85? I love it. 165. If you need to, you can do it over here. Right, 5 and 16.
85.6.
So 165. So then what's 165 plus 92? Yeah, 7, 5, 2. So you get 257 divided by 3. Now listen here. This is kind of neat. Do you know the trick to tell if a number is divisible by 3? Does anybody know? There's a neat trick you can use.
I think it's 2.
Add the 3 numbers
And look for what?
and see if that number is divisible.
Exactly. So if I had the number 257, if I add up all the digits, 2 plus 5 plus 7, what do I get? 14. Is that divisible by 3? No. So then the whole number is not divisible by 3. It's a neat trick that fewer and fewer people know, because unfortunately high school is just not teaching that anymore, or elementary school, wherever it would be normally taught. Some of us know the trick for 9. How do you tell if something's divisible by 9?
is divisible by 3?
Nope.
The third digit is
Nope.
9.
Say again?
Third digit is 9.
Nope. So if I have a what's 9 times 6?
54.
54. I like it. What's 9 times 3? 27. What's 9 times 8?
32.
What's true? 5 plus 4?
9.
2 plus 7?
9.
7 plus 2? Interesting. So if the sum of the digits of the number you're looking at add up to 9, or a multiple of 9, the whole thing is divisible by 9. That kicks ass.
Can you say
That's-
that again?
Yes. So if I let me show you. If I try to create a number 1, 2, 5, 4, 9, 7, 6, what do I have so far? 3, 8, 12, 21, 28, 34. Is that divisible by 9? But if I put a 2, that's 36. Let me try it again. So now if you add up all those numbers, what do you get? 36. Is that divisible by 9? So this whole number is divisible by 9. That's a really cool kind of trick to know. And that's the kind of trick, it's not a trick, it's actually a cool property of 9. So it's just a good fact to know, but we don't teach it as much anymore since the invention of freaking calculators. But I don't want the calculator to know everything. I want to know some of that stuff too, man. So that's a good thing to know.
It's the same as 3.
It's not quite the same as 3. 3 has got to be divisible by 3, so if it adds up to 6, it would work. Here, if it adds up to 6, is that divisible by 9? No. But they are related because 9 is a multiple of 3, so they are related. It's kind of cool.
Somewhere I missed something, because I'm like, it's not adding like you just did for 3, you add across, and if it's divisible 9. If the total divisible by 9 is what you're saying?
So for this number to be divisible by 9, all the digits have to add up to something that is divisible by 9. So these are all added up to be 36. So somebody have a calculator? I do. So if you take 1, 2, 5, 4, 9, 7, 6, 2, and divide it by 9. Try it out. So take that number, divide it by 9. Does it go in evenly? It would come out as a decimal if it went in not evenly, right? Come out as a freaky number? Yeah, it comes out to be...
1, 3, 9, 4.
Yeah, how do you say that number?
1,394,418.
I like it. 1,000,000, blah, blah, blah. 394,418. It went in evenly because there's no decimal part to it, right? That would be the part that would mean it didn't go in evenly. So that's kind of cool. We knew it would go in evenly because the numbers all added up to be 9. This is not the same thing as Jim Carrey's movie 23. Don't freak out. You're not going to start going. Ever seen the movie? It's actually better than you might think. But so going back to this one. That's all aside. That we know is not going to go in evenly. But what do you get when you divide 257 by 3? Let's actually do that the long way. There.
I got it.
How do you set that problem up to divide those numbers?
4 times.
Cool, I like it. So then 3 goes into 25, I like it. You don't say 3 goes into 2 because it can't. So you just get extent 3 goes into 25. Now please, dear God, don't put the 8 there. If you put the 8 there, what does it look like you're telling me? Yeah, you tell me 3 times 8 is 2, that's neat. Right. So 8's got to go over the last number you went into itself, right? So 8 times 3, 24. And then you subtract. Yeah, 1, bring down to 7. Say again? I like it. So 3 goes into 17 5 times. I like it. So for right now, before we get into the decimal section, you are completely allowed to just write remainder 2.
Okay.
Now, anybody know a different way to write that?
2 over 3.
I like it. Another way to write this is 85 and 2/3. Yes, sir.
Slow down. 1 minute, what? Slow down. Like, I don't understand 82.3, what?
Where are we at? Sorry?
No, the 85.3,
The 2/3.
2/3.
Oh, here.
Yeah,
All right. So are you good with me here?
yeah.
Okay, cool. Now let me show you. All right, so let me just make sure. We're all cool with this, right? We all understand long division. And of course, some of us could do the decimal points, but if I don't tell you where to stop, you could just kind of go forever. So don't do that to yourself yet. Now, I want to make sure you understand why this other way to write it makes sense. Now watch this. And this is kind of cool based off of what we just talked about. And I desperately want you guys to realize I will very often kind of veer off from the textbook way of doing things and try to show you a different way to look at something. If you don't quite understand what that is, it's not the end of the world. As long as you can do, the standard way. Do you remember what we just did? We added these up, and I knew it wasn't going to be pretty. Because these didn't come out to be something divisible by 3, right? They came out to be 14. What would be divisible by 3 that 14 is over? What's a number below that would be divisible by 3? 12. If only it would have been 12. So, isn't this true? I want you guys, I really don't know if you guys are really with me. Because this is freaky. I'm showing you why. Now, a lot of you guys just told me you knew that you could write this as 85 and 2/3. Some of us have forgotten or didn't know you could do that. So I want to show you why that is completely fine to do. What I just wrote, is it okay?
Yes.
Hell yeah, because that's 257 still on the top. I just for some reason broke it up. But what's cool about the number 255 now, related to division by 3? What's 2 plus 5 plus 5? 12, which is divisible by 3. So 255 is divisible by 3. And when you divide, so I can write this now as 255, and somebody help me out. What's being divided by 3 exactly?
257.
I love it. So not just 255. 255 is being divided by 3. And 2 is being divided by 3. See that? So I can just break them up like that, and it's still the same problem. I just broke them up. So let me just stop right there for a second. I'm getting a little ahead of myself because we're talking about fractions, and we have a whole section of fractions coming up later. So if you don't quite get what I'm doing up here, again, not the end of the world. We're going to focus on that later. But since it kind of ties into what we're doing here, I want to show you something neat. If I did 3 into 255, we actually know what that answer is. It's going to be 85. Because I would just have a 5 there, and it would go in evenly. Right? Okay, so if you don't trust me, you can do 3 into 255, and then that goes in nice. Right? No remainder at all. So this part is 85 and 2/3. So that 2 on top of the 3 actually tells you how much extra there was. 257 sucks for division by 3 because it's too big. It's got too much. So that part is divided by 3 perfectly. The rest of it would just become a fraction because it doesn't go in. That's why that works. Of course, later when we get to fractions, we'll talk about improper fractions, mixed numbers, that kind of stuff. That's when we get to fractions. Okay. Yeah.
In the homework, it said when you're doing the fractions, it said like divide and check. Well, I was doing it and I wasn't paying attention, and I went down like half the page. And I was like, there's no way this is right. So I flipped back into the section, and it said remainder 2. How do you know when you can put remainders and when you can't?
For right now, until we get to the decimal section, or even the fraction section, this is perfectly fine.
Alright.
If you want to write it like this, that's also fine. I don't mind. That's beautiful. Either one of those is acceptable. But don't go into decimals yet, because none of the problems are going to tell you when to stop.
Right.
And you're like, 6, 9, 8, 7, 2, 5, somebody, God help me.
So like on the test, you can just put like remainder 2, right?
I love it.
Unless it tells you.
For right now, that's completely acceptable.
Alright.
Because again, we have a fraction section and a decimal section coming later.
On this, the way I always learn division, the long division, is, I always want the decimal. This remainder 2, I mean, it's kind of like a new concept to me. I know, like, when I have my kid with this homework, what's this remainder stuff?
But I want you to realize something. From the very beginning, I could have said this. we knew that 3 was not going to go into 257 because it didn't add up to be divisible by 3. Remember, it added up to be 14? So it had 2 too much. So 3 goes into 257 85 times with 2 left over. There's 2 too much. I don't know if that makes sense. That's really what the remainder is doing. It's kind of cool. So here, somebody help me out. Give me a number that 4 goes into evenly. 16. 11. So 4, of course, goes into 16 how many times? 4 times. And of course, remainder 0, right? If you want to be all official about it. Now, 4 goes into 17. I know it goes in at least 4 times. But the fact that 17 is 1 bigger than 16, when 4 goes into 17, it's going to have 1 left over that it can't account for. That's all. I always like to think of it like if I had these weird egg cartons. You're like, what the hell's going on? So say I have these weird egg cartons that can only fit 4 eggs in them. You with me? And I have 17 eggs. Well, how many egg cartons can I fill up? Yeah, I can fill 4 of them up. 4 of them can take care of 16. How much is unaccounted for? 1. Right? So you're going to have either 1 carton with 1 poor little egg, or just 1 poor little egg sitting out there. That's the remainder part, the part that it's in excess. It's the part that divisor can't take care of, because there's not enough of it for it to go into. So 4 goes into 17. Oh, that's nice. Remainder 1. 4 goes into 18. Remainder 2. That makes sense because 18 is 2 over 16, the number that it goes into.
So remainder means it's like it's like 1 out of you take it's like a pizza, and then it's like you have 17 slices, and so it takes there's 16 and then there's 1 left. So it's
Sort of, yeah. How much can that thing take care of on its own? So 4 fours takes care of 16. So if you have 17, you're going to have 1 left over.
it's like
Right?
There's 1 left.
So if I can eat half a pizza, I'm going to eat half a pizza and have a half left over. It's how much you can take care of. All right, that's enough of that. Okay, so again, for right now when you're dividing, you can certainly leave it in remainder format. When we get into fractions, decimals, then I'm going to want it in those formats specifically. You can certainly leave it in decimal and fractional format if you want to. That's beautiful, if you want to do it that way.
How do you check your work when you have remainders?
Who just asked? Okay, so the one we just did was this, and we got 85 remainder, what was it, 2. So the way to check this is 257 is supposedly 3 times 85
Right.
plus 2.
Oh, okay.
So you work that out and you verify that it does equal that. That's that 2 excess. So if it was 255, that would be 3 times 85. 256 would be 3 times 85, remainder 1, so plus 1.
Okay.
I like it. So that remainder is how much over a nice number you are. A nice number being I would go in evenly. If only it was freaking 255, we'd go in evenly. But this stupid thing is 2 over. So it's remainder 2. How we doing? Okay, so any other questions from homework? Okay, so again, please, dear God, do not let me steamroll you, right? Do not feel like I'm just not going to ask you questions because I'm too far behind. And if you're bored, kick ass. Enjoy that while it lasts, right? Okay, so I kind of want to go a little quickly. So as always, slow me down. Through 141516, so I can really focus on 1718.
What's the decimal mean? The decimal, the dot?
Oh yeah. So in our future, we have a whole section devoted to decimals, and we'll talk about what the places mean and how to round them, how to multiply them. But that's coming later. Yeah. Okay. So section 1.4. biggest mistake I see with rounding, I'm going to try to correct that right off the bat. I'm not going to show you the mistake first. I'll show you the mistake here in a minute. So if I have the number 542, and I want to put that on a number line, what two hundreds is it between? What is 542 in between in terms of hundreds? Yeah, it's in between 500 and 600. So the whole idea, of course, of rounding is just saying it's closer to this than that. So I can just approximate it using this. So I wouldn't tell somebody, 1,947 people. No, I'd say about 2,000 people came, right? That's just everyday conversation. We don't want to get too specific sometimes. So if I wanted to round 542 to the nearest 100, that's exactly physically what you do. What is the closest 100, 500 or 600? 500. Exactly. So you'd say 542 is approximately 500. Now the mistake I often get is I get somebody telling me this. Now, what did that person focus way too much on? The number, not the place, because now this is not in the right place anymore. 542 is not about 5, right? I feel like there's 542 people coming, and this guy's like, how many people coming? About 5. This guy's not going to be ready. He's going to be like, what the hell just happened? If it would have been, do you guys understand that? So if I'm talking about nearest hundreds, my answer better come out with that number being in the 100 spot. So that's why it's about 500. Yes, sir?
Because I think that's why you went to 500, because it's not even 5 yet. It's not
Exactly. Where's the weird possible spot? The one that's kind of equidistant from both.
550.
550. And what do we give that guy to?
600.
Yeah. Right. Just to kind of make it fair, actually, there's the same amount of stuff in here as there's in there. We make 550 go up to 600. That's the first number we would make go up to 600. Cool. So it gets a little freakier when we have more numbers in the way. Right, that was not too bad. That was just in the hundreds. So what if I had, let me give you a number. Okay. So let me see. Let me let you guys attack this, and then we'll talk about it. So round this to the thousands, tens, and say 100,000s. Yes?
90 on the 10s.
Oh, hold on. Don't say anything. Sorry. Go ahead and write it down, and then we'll talk about it. So let me kind of do this first one with you to make sure everybody's on the right track. When you're rounding, the first thing to do is to find what? In this case, I want to find what's in the thousands place currently, right? So what number is in the thousands place? 7. I love it. So the first step is find the place that it's referring to. What do I look to now to tell? What could that 7 do? It could either stay... It won't go down. It'll either stay 7 or go up to 8. I like it. And it all depends on what the next number is. So this is 1,257,000. So this piece of it, I really want you guys to understand. That 1,250,something thousand is still going to be there. If you take that away, that's like saying a million is about 7,000. Sure. You want $1 million? Here's 7,000. You're happy, right? No, screw that. What the hell? So you don't want to lose the first part of it. You're just saying, does that number stay 7 or does it become 8? And of course, I look to the next dude. Is that closer to 7,000 or is that closer to 8,000?
8,000.
Because it's past the midway mark, right? So the shortcut we should all know is if this number is 0 to 4, that number stays. And if it's 5 to 9, that number goes up. So that number was from 5 to 9, so that's going to go up to 8. So again, the big mistake I see is that somebody just writes that. And what's wrong with that? It was 1,000,000 and somehow you just made it 1,000. How the hell did you do that? What should happen with the rest of that then? I love it. Should become zeros because we just said this is closer to 8,000 than it is to 7,000. So everything after that number you're rounding will become zeros. I like it. How are we doing so far? Okay. So you guys do the last two there. Don't say anything out loud. Hold on. Yeah.
On the homework, is it easier when I box that but it's cramped?
Oh yeah, please. Yeah. I'm glad you asked that. In general, on your homework, make sure I can find your answer very easily. If I have to search for your answer, I probably won't. Right, I'll just say, well, you didn't get an answer with it. So box it off. Make it easy for me to find that thing.
For the homework, you want us to write the question
I
out?
used to highlight, but you said we can't use
Yeah, you don't need to write the question now unless you want to.
Okay, cool.
Yeah.
Are we allowed to highlight the answer?
Oh yeah, you can highlight the answer.
I didn't know.
You can use different color stuff. I love it. My AO retentive students are awesome. Yeah,
Clay said on the homework, you want to see us to work it out.
definitely. But when I see a lot of work and I'm like, if people put the answer somewhere, they don't box it off. I'm like, where's your answer? I can't see it.
Next page.
Yeah.
I usually scramble those stuff everywhere.
So what happens on this second guy?
That's 90.
Yeah, the 9's in the 10's place?
No. Yeah. No.
Yeah.
Yeah. But not a 4.
So what stays the same?
Everything.
Yeah, 1, 2, 5. Those all stay exactly the same, definitely. Now, what's going on here? Does it go up or does it stay? Stay. So now, how do I finish this out? Yeah, 90. So 94 is closer to 90 than it is to 100. That would be kind of freaky. How are we doing so far? So it's that next number after the place you're interested in. That's the one that tells you to tick it up or to leave it where it is. So some of you guys I know are really good at this. That's awesome. Just hang out. Some of us, been a while. What about this last guy? Who's in the 100,000s place? So let's see. We got ones, tens, hundreds, thousands, 10,000s, 100,000s. Exactly. And if you need to, you can just kind of count it out like that for yourself. Because it really sucks to start with the wrong place. You're guaranteed to get it wrong. So I'm looking at this 2. So just the 1 is guaranteed to stay. So I found the place it's talking about. What tells me if it's going to stay or go up? Yeah, the next number over. Since that's a 5, it's going to go to a 3. And then you just make sure every other number becomes 0. There you go. So 1,200,000 stuff is closer to 1,300,000. That's what it's closer to. Make sure your answer is as big as your question was, right? Because the big mistake I get on this problem would be somebody would tell me the answer is 90. And they're just focusing way too much on this piece. What the hell happened to the rest of my money? Give me $90 lottery board. I won 1 million. Yeah, taxes. I like that. Yeah.
So what if it's like 95 or 96? Gonna be like
I like it.
100?
I didn't want to do that one yet. I want to make sure we're all cool with rounding in general. The weirdest situation in rounding is a situation like this. And I want to round to the 10's place. Now, if I wrote 996 On this side, what's the 10 on this side? 990. Let me just stop there. Is that cool? That's the 10 that's on that side. 990. 996 could either go to 990. What's up here then? It's got to be 1,000. Exactly. How far apart are these two things? 10. You see how that's the trick? I'm going to the tens place. The two possibilities have to be 10 apart. It's kind of cool. So what happens is, if this guy has to get bumped up to a 0, it's like carrying a 1 over there and bumping him up to 10. You guys with me? He's got to bump up to 10. He carries the 1, makes him bump up to 10. So what exactly is going to happen? Here's the tens place. Sorry, anybody else sick? I love it. So I'm going to do the halls. So I don't know if it's going to mess up what I'm talking. So there's my tens place. The next number is a 6. That's 5 or more. So I've got to take that up. I can't squeeze a 10 in one spot. So that 1 actually just carries there. So it's going to become 1,000. Let me put approximately. Yes, sir. Oh, yeah, good. Okay. Does that all sound vaguely familiar to most of us? Or?
Can you
Yes.
repeat
Yeah, let's do another one.
Ask your random question.
Do what now?
Random question. On the book, you said bookrenter.com. How long does it take? How many visitors?
Anybody do bookrenter.com?
Yeah, it took about 5-6 days.
Okay.
Thank you.
Not horrible, because that would, some places take 2 weeks. Overnight took 3 or 4 days. I'm not. They just sleep a long time. I think.
A long night.
Hey, dude, it's been only one night. No, you've been asleep for it. So another problem like this. Let's see. I'm going to round to the hundreds place. So what number's in the hundreds place? Yeah, so 14,973. And I don't know if you guys are getting what I'm trying to do here. This is not a bad visual for yourself if you have any trouble with rounding. The two possibilities would be 14,900. I'm focusing on just the 100 part of the problem. But then what must be on the other side? What's the other possibility? Yeah, because what's 100 more than that? 15,000. So 14,973 would either round down to 14,900 or round up to 15,000. It's like that odometer rolling over and making the other number roll over too. It's the same idea. So of course, which way is it going to go?
15,000.
Exactly, 15,000, because that 7 says it's got to go up. I can't fit a 10 there, so carry the 1, it makes it 15,000. So this is approximately 15,000. I keep using this symbol. You guys ever seen, it's either that or sometimes you'll see just that. Either way, it's cool. That just means it's approximately.
What if you didn't do that?
Then you're telling me that that equals that, and that's freaking me out.
What if you forgot that shit?
Now you won't.
Yeah.
Yeah.
So when you get my homework, you know. I forgot about it.
All right. Well, that's and that's a simple thing to remember. It's not a huge deal. Right now, I'm more concerned with are you able to do the process? That's just a little cleanup. It's not a big deal. Is that cool? Who asked for another question? Is that all right?
Yeah.
Okay.
Okay.
Okay. Section 1.5. I think the freakiest problem out of Section 1.5. I'm not overly concerned with the properties yet. And of course, let me give you a problem to do. Okay, so go ahead and attack that. Obviously, don't use a calculator. You can use one to check yourself. Sorry? Oh, this is 1.5.
7 times 1.
Oh, hold on. Whoa. Don't tell me yet. Not until I ask for the answer. Don't tell me. It's all right. Don't worry. Again, this is not a useless skill to have. I know calculators can do this all day long. What do you do? This is still good for us to know the basic process. And really, if you really want to see, you've probably seen this before, but why does this work the way it does? Let's see how this works first. How the hell does this work? You do, 5 times 8, 40. So you put a 0 there. 4 there. For some reason, I've had people in the past that would put the 4 there and the 0 there. But it's 40, so the 0 and then the 4's got to carry over to the next spot. Okay. And then you got 5 times 2 plus 4. 14. So the 4 goes there, the 1 carries. 20. So the 1 goes there, the 2 carries. 5 times 1 plus 2. Okay. Now, what do you do in the next line? Do you say 1 times 8 is 8?
No.
Hell no. Because that's not really 1, is it? What does that 1 really represent? 10. So 10 times anything is going to have a 0 at the end. Right? And then 1 times 8. And now the beautiful thing about 1 is these are all just going to repeat. 1 times 8, 1 times 2, 1 times 4, 1 times 1. You can basically just write the number down again when you have a 1. Kick ass. And then you just add those. You guys with me? Yes, sir.
But aside from 1,700, 140, 1,700, and 7,140, but I didn't know that.
So if you just say it's 7140, you really just did 1428 times 5. That's all you did. But now I really want you to understand. Now watch. Now stay with me. 1428 times. Let me just do it like this. Times 15. Now, of course, really soon we're going to let go of that x as multiplication because x is going to mean all this weird other stuff, right? But that's okay for right now. Go with me now. This is 1428 times 10 plus 5, right? This is getting a little ahead of us, but I have to get a little ahead of us to explain why this works the way it does. What am I multiplying 1428 by? 10 and 5, right? So 1428 times 5 is 7140, but I have to add 1428 times 10, or else I haven't multiplied it by the whole number. So that's really what these two mean. This is 1428 times 5, and this is 1428 times 10. So the whole process is actually built off of breaking this up into 10 plus 5, and then multiplying each of those pieces one at a time, and then adding the result together. How are you guys doing? I don't know if you guys have ever seen that explanation before. So if I take some smaller numbers for a second, we're not done with that, by the way, but we're going to get back to it. If I do 3 times 8, of course that's 24. Well, somebody tell me what 8 is, what plus what? 4 plus 4, 11. 3 times 4 is 12. 3 times 4 is still 12, Jeff. 12 plus 12 is 24. So no matter how I break that second dude up, as long as I multiply the first two by both parts, it's still the same answer. Mathematically, I'm still doing 8. Because I did 4 and then 4, so I actually just did 8. So this is always based off of breaking it up into parts and then adding those parts back together.
But
What's up?
I don't get it.
Because here, let me see. So if I have 3 times 4 plus 4, I have to do 3 times 4.
So that'd be wait, the 4 plus 4 is 8, right?
That's right. That's where I got that 4 plus 4 from.
And then you times by 3 is 24.
I know, but I want to do it a different way. I don't want to put the 4 and the 4 together. I want to leave them separated. But then what I have to do, what do I have to multiply by 3? 4 and 4. So 3 times 4 is 12, and 3 times 4 is 12, and I still get 24. Now this is the distributive property. I don't know if you guys have ever heard of that, distributive property. If you haven't, don't freak out, that's in our future. But that's a shortcut for what I just did. But all it's saying is what's in here? 2 4s. So the 3 has to go to both of them because it's in front of both of them. It's got to get distributed to both of them. Okay. So even if you don't understand what the hell I just said, as long as you know the process of multiplication, you're fine. I was just trying to explain why it works the way it does. So how do I finish this out? Add it. So we get 0, 2, 4, 1, 2. I like it. So on some tests, I'll have a part 1 and a part 2. Part 1, you can't use a calculator. Then you turn that in, you get part 2. And on that one, you can use a calculator, but I still need to see your work, but at least you can check your work. So anytime I let you use a calculator, I still want to see your work, but at least you can kind of back yourself up by checking it. Which means if you don't know how to use your calculator, you're going to be telling yourself you're wrong when you're really right. It's not good. Okay. The other part of this section is that, oh yeah, this is where they talk about area, and this is finally catching up to a question I had earlier, right? The area question?
I think you went to the bathroom.
Oh, okay. You just kind of gave up on me. He's never going to get my question. What shape am I trying to represent here? I pretty much have to tell you because I'm trying to represent a square. A square, of course, is a shape where what's true? All the sides are equal and they're all at right angles, right? If it was tilted, it'd be a rhombus, but let's not go there. So if this is 6 inches, the whole 6 inches, I love it. So the first question I have for you is, who knows what the perimeter of that would be? I like it, sort of like it. You never have to memorize any perimeter formulas. In fact, it's better if you don't. The perimeter of any shape is you just add all the outside sides, right? Where do you normally hear the word perimeter in a movie?
The outside perimeter. The perimeter is the outside protected.
Exactly. What do you do when you're all in a camp and there's a monster out there? You have people walking the perimeter, right? So how long it takes them to walk around your camp, that's the perimeter of your camp, right? And I want more of those people out there so the monster don't come in there. So the perimeter here would be 6 and 6 and 6 and 6, which is shortcut would be 4 times 6, I agree. So that would be 24. Now here's where things get freaky. What are the units on that thing?
Inches.
Inches, I love it. So we're not freaky yet. So I haven't, I'm still talking about straight up length. The minute I start talking about area or volume, I have to use different units. I love it. So if I want to cover the floor, the easiest way, let's talk about the ceiling. Well, those are rectangles. The easiest way to cover a plane is to use just squares. So when I say, for example, if I look at this thing, talking about area, I have 6 there, and I got 6, add 1 there. This is like the world's biggest tic-tac-toe. Oh yeah, 1, 2, 3, 4, 5, 6. I like it. 1, 2, 3, 4, 5, 6. I like it. Cool, we got 6 inches by 6 inches. So see how I've got a bunch of little square inches? The little squares covering that. So I'm really just counting how many of those squares do I have. So how many of these square inches? Because it's inch by inch. 36. And the shortcut, of course, is 6 times 6, 36 to cover the floor. I like it. An even more direct reason why the unit is squared is because area, what's the area of a rectangle in general? I love it. Length times width. Cool. What's the length? 6 inches. Width is 6 inches. 6 times 6 is, and what's inch times inch in square. We're going to talk about exponents here in a little bit, but hopefully that's okay. Square just keeps track of how many things you're multiplying. Yes, sir?
No, wait, like what?
So the area formula for rectangle in general, the area formula for a rectangle.
Wait, so 6 times 6, wait, for like 6 squares, 6 squares, 6 squares, 6 squares, it's like...
Yeah, there's six, every row's got 6, and there's 6 rows. So if there were 6 people in each row, and there were 6 rows, how many people would there be? 6 times 6 is 36.
36.
Right?
Yeah.
Cool. So that's all I'm doing. There's 6 rows, and there's 6 people in each row. So how many total people would be each one of these little blocks? 36. I love it. And it's going to be square inches because they're little squares.
So can you like times by 2? It's like that's for the 2?
No. So we'll get into exponents here in a little bit. But basically the units on area will always be squares. Because how do you cover a floor or something? You can use squares to cover a floor. How do you fill a room? You can use boxes. You can use cubes to fill a room. So volume would always be cubic something. Because you're talking about how many cubes can you use to fill a room.
Oh, that's cool.
That is cool. Okay. So right now, you're not going to see a lot of intense geometry. You're just going to see a square or a rectangle at the most. So that's just length times width. I like it. Just remember that your units have to change. Because now you're doing actually 2 dimensions. Right? You're going 2 dimensions at once. Okay. So that's section 1.5. It's mostly just a bunch of multiplication.
Hey, I have a question just real quick on 1.5. Like, for instance, question 53, where it's got 20 parentheses 7, parentheses 4. Would that be 20 times 7 times 4? Number 53.
Oh, you're in the review probably, right?
On page 89.
Gotcha.
I just want to make sure I'm reading that question right. Would that be 20 times 7 times 4?
I like it. So 53 says 20. And when you see parentheses like that, that's what we're going to use instead of an X. Because again, an X, of course, we all know that means who knows what yet. That's the variable. So you see parentheses like this, that means multiply. So this is 20 times 7 times 4. How the hell would you do that? Yeah, you got to do it in parts, right? I can't do 20 times 7 and 4 all at the same time. Screw that. So what's 20 times 7? Good. 2 times 7 is 14. Add the 0. And now you can do 140 times 4. You can do that 4 down there. 560.
That's what I make sure I was reading right.
So why would a problem like this here, why would this problem be easy? Even if let me add on some stuff here. Yeah.
0.
Yeah. Please, dear God. Do not 20 times 7 times 4 and you start crying. So freaking mean. No, because I can see there's a 0 in there. It doesn't matter what the hell's in there. The whole thing is going to multiply to be 0. 0 will kill all these dudes, right? Whatever monster ugly number you get after you multiply all this stuff, times 0, 0. Times 10, still 0. 0 kills the whole thing. So look through the whole string first. If there's a 0 somewhere in there and it's all multiplication, 0 is the answer. Don't do any work.
Well, if it's the 20's got a 0 on it, so right there, wouldn't that be a...
Careful now. 20, though, is not 0. That 0 just means no ones. This 0 means no numbers. There's nothing there at all. Is that cool?
No, you said it.
So, I still don't get it. I just don't get it.
For which part?
All of it, like the 53 slash 20 slash 7 slash 4.
All right, so this was just problem number 53. So if I have, let me show you another problem. If I had 2 times 4 times 3, if that was my problem, how would I do that?
It's 12.
Okay, you can do that. So this is 12. What do you still have there you haven't done?
1.
Have you done this yet? So this is 2 times 4 times 3, and I love the fact you went with the 4 times 3 first. But what do you still have to do?
1.
So you replaced, now watch, this is kind of nice. And when we get into solving equations, the biggest mistake people make is a mistake that people make on this problem. You don't keep yourself organized. You forget stuff that was there. So equations, if you keep yourself organized, you'll be so much better. You don't want to do things in pieces, parts.
So that's 12 and that's 6.
So if you rewrite this, you ready? You got to be careful. This is 2 times 4 times 3. So going off of what you first said, I could rewrite this as 2 times... Yeah, what is 4 times 3?
12.
What is 4 times 3? You said it earlier. Sorry. Yeah. So you replaced 4 times 3 with 12. Beautiful. But what's the problem say? 2 times 4 times 3. So you did this and you replaced it with 12, but the 2 is still there. So all you did, so when we get into order operations.
Wait, okay.
Now watch, real quick. I want to go back to something you did earlier. Remember this problem earlier? What's the easy way to do that problem?
12.
You did this earlier, it's beautiful.
24.
Yeah, because what's this?
That's 15. That's 12. That's 16. Wait, that's 12.
So 4 plus 4?
8.
8. I love it. So you told me earlier, 4 plus 4 is 8. So what did you just do? I want you to... The 3 is still there. Because you haven't done anything with the 3 yet, but you replaced 4 plus 4 with what it's also known as. It's also known as 8. And then you do what's still there to be done. 3 times 8? 24. Now, this is exactly the same kind of problem. You took 2 times this. But this is what? What's this? What's 4 times 3?
12.
12. So it's 2 times 12. And what's 2 times 12?
24.
Done. So you can do a part of a problem. That's exactly what you have to do. You replace a part with what it's better known as. So if I see 5 minus 3 somewhere in some big-ass problem, I'm going to replace that with 2, because that's what 5 minus 3 is.
That's amazing.
Okay? All right. Oh, where am I at? 1.6. So I'll tell you what, we're sort of there. We talked about division a bit already. So it's that long division. So if it's been a while since you did a long division, you want to get back into it. Does anybody do long division differently than what I did? So I do long division like this. Set it up like that. Does somebody set it up a different way?
Are you
You'll have to show me later. I know that in some European countries, they do it in a different format.
No, I was just going to say, I do that same way, I just don't do the remainder.
Oh, okay, I got
Just
you.
go decimal.
But some people set it up, they started off in a different format. So I just wanted to see if anybody did. It's sort of like the thing with the commas and the decimal points interchanging. Same idea? You'll have to show me later.
Okay.
Thank you. So 1/6 I'm not going to talk too much about because it's all about dividing. So we've already talked about it. What's the only number you got to be careful with when you're dividing? What comes out freaky? 0. Yeah, you can't divide by 0, right? That would come out to be what?
Undefined.
Undefined, right? There's no number defined to do that. So now we're going to get into the 2 sections I want to slow down on and take some time with. 1.7 and 1.8. So I'm going to start with exponents, explain what the hell they are, and then get into order operations. Order operations is sort of the grammar of mathematics, and that's why a lot of people normally hate it, because when we first learned grammar, we hate that too. Well, let's start off with exponents. Bless you. Now, let me see. Let me ask you that. This is getting a little... We did this earlier. We did this... you guys did something interesting when I asked you this question earlier, when I said, what's the perimeter of this? I heard a lot of people say 6 times 4. Right? Didn't you guys say that?
Yeah.
And that's beautiful. There's nothing wrong with it at all. But it's 6 plus 6 plus 6 plus 6. Well, what's a more concise way to write that? Yeah, there's 4 6s. So multiplication, of course, is built off of addition. It's repeated addition. 4 times 6 really does mean you have 4 6s added. You guys kind of with me? Okay, cool. So some dude somewhere in the world, millions of years ago, not millions, thousands, he had to write 6 plus 6 plus 6 plus 6 all the way through his paper. He got tired of doing it, so he said, I'm just going to write 4 in front of the 6. And he called everybody up on his cell phone. And he says, that means I have 4 6s adding. And they were all like, oh, that sounds good. What the hell? So if I have 7 plus 7 plus 7, 80 freaking times, I don't want to write that. I'd much rather write 80 times 7. They mean the same thing. Is that cool? So it's just one thing math does is try to write things concisely, but then the rest of us have to go and interpret what the hell people meant by that. That's why math is difficult. So what if I had 6 times 6 times 6 times 6?
2 6 2 4.
I love it. This poor dude was like, I want to do this. I want to put a 4 in front of 6, but this dude already did it. Damn. Because everybody now thinks that means addition. I'm like, shit. So one thing about math that I love to try to get people to understand is it could have been totally different. Why is this written like this? So he said, let me put the 4 there. No, that looks like division. Let me put the 4 there. All right, that just looks weird. So he said, let me put it there. What the hell? Right? As long as other people agree and understand what that means, we can then communicate. That's why math is a language, right? But that 4 could have went somewhere else. That could have meant this. It was all decided upon. And we're just catching up with what all these people did 1,000 years ago. You guys kind of with me? Yes. Yes, sir. So here, you agree with me? A little bit? So repeated addition is what multiplication is based on. 4 times 6 means 4 6s added.
So wait. So you add 6. It's like you go in like 30, okay? 30, and you have 5. All
right, cool. So if I did 5 plus 5 plus 5 plus 5 plus 5 plus 5. 1, 2, 3, 4, 5, 6. What's a more concise way to write that?
To make it 5 times 6 is 30.
11. 6 5s adding. That's what multiplication means. So that's nice, and that was a way to write things quicker. So this guy on the other side of the world said, oh man, that sounds cool. I want to write stuff quicker. And I got a bunch of multiplication. So I can't write it the same way he did, because everybody thinks that means addition. So I have to write it a new way and tell everybody what the hell that means. And this guy didn't like it. I kill him, and then everything's good, right? A lot of math actually is very violent history. So if I wrote 7 to the 5th power, what would that really mean?
7 times 5.
Yes, 7 times 7 times 7 times 7 times 7. Is that cool? If I wrote 5 times 7, that really means 7 plus 7 plus 7 plus 7 plus 7. Okay. You guys with me? So all exponents are a way of writing something more concisely. That's all. How are we doing?
Good.
Yes, sir. I have a question now on that one there. When he said 7 times 7, would it be 49? 49 times 7, that outcome would be times 7.
343 times 7.
Okay,
exactly.
So, big number,
so exponents grow very quickly. In fact, in some horror movies, don't you hear like, the blob is growing exponentially? That's what they mean. It's growing that quickly. And that grows pretty damn fast, right? Okay. I watch too many horror movies. So do we all feel decent about that? So let me show you a couple of areas to be careful about. One thing is, what if I wrote this? And I want you to write that in exponential form.
2 to the 3rd power.
I like it. You cannot write it in one concise way. You have to actually break it up. I have 3 2's multiplying. And I've got 4 3's multiplying. Cool. So real quick, if you see that, I always freak my students out when I say there is no 4 in there. And like, Jeff, man, there's a 4 right there. But do you see what I mean when I say there is no 4? That number is just how many 3's I've got. I don't have any 4s in there. Because people will sometimes tell me that's 12. And what did that person do?
They just read them.
They 3 times 4, but there isn't a 4 in there. It's telling you how many of these you have to multiply out. Is that cool?
So,
But you see now, how many 2s do I have up there? How many 2s?
3,
3 of them. And what is the operation?
6,
What is the operation?
1,
Is it addition, subtraction? What's going on?
minus.
There's no minus.
Okay, why is that? Why?
So this symbol here, this is my fault probably. This means 2 times 7, right? But we're not going to use that anymore because very soon we're going to have x as a variable in section 1.8. So we saw 2 times 7 like that. Or I could do 2 times 7 like that.
21, right? 21.
3 times 7 would be 21. But I don't want a number right now. I just want how many 2s are being multiplied.
2.
No, how many 2s are being multiplied? How many of them?
3.
3 of them. So exponents are based on multiplication. If I have the same thing being multiplied over and over, I can consolidate that together. I have 3 2s multiplied. So exactly what is it about this expression that tells me that that's multiplication?
The exponent.
The exponent, the fact that it's up there. That's all. If I wrote this, that tells me that it's based on addition. I like it. 3 2s adding. 2 plus 2 plus 2.
I'm sorry, I still don't get it. I don't
That's all right. Here. You guys try this one out, and then I'll talk about it.
Knock it out, right?
So write that in exponential form. Don't overthink it. Just whatever number you see repeated, you raise that to a power. So I don't want to see like 25. I don't want to see a number. I want to see 5s and -4. You just tell me how many of each you got.
In the homework, when it tells you to write it like that, what's exactly saying? So people don't get confused. Like
Oh, what does it say in the homework? It says write it.
You know what I mean?
Yeah.
Some people don't get confused and actually do it.
So like on page 71 in 1.7 homework, it says write using exponential notation. Right? Exactly what I just said. So write using exponents, using exponential notation.
So you don't have to
So
do
just,
it.
so I'm
Exactly.
not doing.
You don't actually have to multiply it out. Oh, good. Okay. All right. Thank you. See, please help me. Sometimes I'm not sure what it is that's not getting through. So that helped me out a lot. That's what wasn't getting through. I don't want to know the answers because the instructions will say write using exponential notation.
It doesn't say solve.
It doesn't say solve. It doesn't say evaluate. It doesn't say simplify. It says rewrite using exponents. That's what I would say on our test. The book says use exponential notation. You key on the fact that it says exponent. That's all I care about. Rewrite it using exponents. So don't give me this big ass number. I don't want that. I just want what would happen here. How many 5s do I have multiplied?
2.
So I'd say 5, and I got 2 of them. Right? There's a 5, and I got 2 of them multiplied. And then what do I have here?
-4.
A -4, and there's
3 times
3 of them multiplying. That's why it's an exponent. So if they're multiplying the same thing over and over, that's an exponent. If they're adding the same thing over and over, that's what's called a coefficient. Yes?
Is there an appropriate and inappropriate time to use parentheses versus the dot for multiplication?
The reason, does anybody have any idea why I had to put parentheses in there?
Because of the negative.
If I wrote it without the parentheses, it would look like that. And then that's subtraction. Right?
And the answer though.
Yeah, in the end.
Oh,
Right, the dot.
Could you put the dot? negative
same
one?
problem. If I wrote it like this, doesn't that look like subtraction?
No, if you put the dot first.
Well, the dot can get lost with the minus sign.
Oh,
So math doesn't like several signs together. because then they very often can merge. So we'll see later, like if I wanted to say 7 minus -2, I've got to do it like that. I have to put that guy in parentheses so I can see there's two separate minuses. If you wrote it like this, later on, they might, your eyebrows might merge, right? Bam, and just become one big eyebrow. If you keep it separate, you'll see there's a minus and there's a negative. They both got to be there.
I have a question. On the dot, that means what, multiplication?
I love it.
So wouldn't that be 5 times 5? But up there, that's 5, 2. Would that be what, 10?
No.
I mean,
No.
5 times 5 is 25. Minus
Exactly.
4,
now be careful.
Minus 4.
Careful. The only way to get 10 is to say 2 times 5. That's how you get 10. It's not what I said. I said 5 squared. And it's because of the fact that the 2 is up in the exponent. It's up here. That's what tells me it's based on multiplication. I don't want to add 5 to itself. I want to multiply 5 to itself. Does that make sense? I mean, we wanted a quick way to tell somebody, this means add 70 11s. So it'd be 11 plus 11 plus 11, dear God. Is that cool? This means what?
11 times itself, 7
Yeah.
times.
Multiply 70 11s, right? So forth. So I'm not going to write 70 11s. They got. Yeah.
So wait, -4 would be -12, right?
If I was adding them together, then I agree with you. -4 minus 4 minus 4 is -12 if I'm adding them together. What am I doing with these? Multiplying.
It's like 10 minus 14, like 10 last 14, right? It's like 25, like.
So I don't want to see the number. I don't want you to actually do the work. The funny thing about exponents is, have I done any work? No. Not really. I've just collected how many of these I've got to eventually multiply. I've got to multiply 2 5s. And how many of these do I have to multiply? I've got to multiply 3 of these. So this is how I can write that more concisely. So you're not actually multiplying them. You're definitely not adding them. Right? And what is it about this that tells me I'm not adding them? I'm not combining them. Yeah, they're sitting next to each other. Anything sitting right next to something else, like this, means multiply. Right? I could put a dot in there to make it even more meaning that. But if I had this, I agree with you. That would be -12. Definitely. Because I'm actually putting those, it's -4. Take 4 away from that. Yes. That means multiply. I like it. Cool. Yes, ma'am.
Would I be wrong if I did my exponent inside the parentheses on the -4, or should it always go on the outside?
So in general, yes, you got to be careful. That would be wrong.
Okay.
And you kind of led me right to my next thing. So let me do one that's not freaky, and then I'll do the freaky example. Just to let you know. And here I'll tell you, expand that, and then tell me what the answer would be. So what is it if I expand it?
3 times 3.
And of course, when I do that, what do I get?
81.
Exactly. A quick way to do it would be 3 times 3 is...
9.
Well, there's 3 times 3, that's
9.
9 times 9.
81.
So if you multiply 3 by itself 4 times, you'll get 81. I love it. And now you're sitting there saying, how does that relate to my question, John? Don't worry. Here's the 2. I'll put them both up here. Here's the 2 evil ones. There's a difference here. Those are not the same answer.
Got it.
And I desperately want to get that understood right now. Now, an exponent can only go so far. What is that exponent sitting on? What is it hovering over? The 2. So what is there 2 of? 2 2's. How many negative signs are there? 1. So this would be a negative sitting in front of 2 times 2. And what's negative 2 times 2? Negative 4. I like it. Because the only way to make that negative disappear is if there's, I love it, another negative. 2 negatives cancel each other out. and make a positive when you multiply. Right? Because, and real quick, let me finish this out and then let me talk about the negative thing real quick. Because that always trips us up. Here's my... Just like here, this means 3 negative 4s. That would be negative 4 times negative 4 times. What? So how would I write this? 2 whats?
Negative.
So that would be...
Negative 2.
Negative 2.
Negative 2.
And the 2 negatives
Oh, positive.
cancel. So you get 2 times 2 is 4. So let's talk about that real quick. So I'm sure there's a lot of you guys out there that have the question, why the hell do those cancel? So let's explore this negatives, why they work the way they do. See, I want to keep track of how much time I got.
Field trip.
Yeah, field trip. We've got to fit that in. So if I ask you, what is the opposite of 5? What would you say? Yeah, what's your gut tell you? The opposite of 5. Negative 5. Why would that be the opposite? Because together, they become 0, right? If I put 5 and negative 5. If I have $5 and I owe you $5, I pay you off, I got nothing. Right? So those are opposites. So negative, then really that negative sign means the opposite of blank. So when you see negative 5, that actually means the opposite of 5. How are we doing so far? Is that decent by itself? Yes, sir.
Number 4, you said that negative 2 squared, 2 to the second power, and then you got negative 2.2. That's 2.2.
No, it's a 2 times 2.
2 times.
Yeah, I'll try to make sure my decimals are like down there, and my little multiplication dots are like up there. Yeah. But always ask me on if on a test you can't tell, is that a decimal or not? Always ask me.
So the decimal is multiplication.
Decimal would be down on the ground. The dot in the middle of two things means multiply. But I could also write that like that, and then there wouldn't be any problem. It still means multiply. Right? That would be negative 2 times 2. But I am going to probably just use a dot because I'm lazy, and it's quicker just to make a dot. Yep.
So what happened to 2? That 2, 2, 2. He's like a 4.
This 2?
The 2, yeah. Yeah, the 2.
So this, an exponent tells you how many of these you're multiplying. So how can I rewrite 2 squared?
That's 24.
I got 2 2's multiplied. So if I had 7 cubed, 7 to the 3rd power like that, you with me? That's 3. 3 7's.
21.
No. It's not this. This is not the same thing. That's 21. Exponents mean multiplication. So this means I have 3 7's multiplied. It'd be 7 times 7. So I have 3 7's multiplied. That's what it means.
28.
No. You'd actually have to do 7 times 7, which is 49, times 7, 343. You'd actually have to multiply it out, right? 7 times 7 is 49. It's already big. And then times another 7, it gets up to 343. Okay. But coming back to this, I want to focus on this negative stuff. So if I said this, how do I say this in English now? What did I tell you that the negative sign really means? The opposite of. So this says, what does this say then in English? The opposite of? The opposite of 5, right? So what would that mean? So I kind of relate this to about face and then about face again. Well, I'm back to the same direction, right? So that negative is kind of a way to say about face. It kind of turns the thing around. So if I turn 5 around and make it negative 5, and then this guy turns it back around, it's going to end back up at 5. That's really why 2 negatives canceled. It's actually more of an English thing. The opposite of, those cancel. If I said, and this is technically not right, but if I said, I'm not going, okay, what the hell does that mean? I'm going, probably, right? Because the two nots, what do? Cancel each other out. It's just a way of emphasizing it in English. But it's kind of nice that in language, it's the same thing that math does. Because this does mean not 5. So what's not 5? 5? Yeah. Is that cool? Now, if I had this, that's not the same situation, right? This is what operation?
Negative multiplication.
Multiplication. I love it. This is negative times negative 5. What operation is going on here?
Negative 5.
Subtraction. I love it. So when you multiply two negatives together, they cancel. Because it's the opposite of the opposite of. This is like money always helps. If I owe you $5 and I owe you $5, overall I owe. So it can't be positive 10. That would mean I got $10. I'm good. It's negative freaking 10, right? This says negative 5, go down 5 more. So I'm going to end up at negative 10.
So how would you write that? Negative, are you saying negative 5 minus negative 5?
No. Definitely not. That would be something totally different. This is negative 5.
Minus 5.
Minus 5. Good. And what happens when I take 5 away from something? It goes down. So one way to think of this is, if I'm already 5 down, if I subtract 5 more, I'm getting even more negative. So now I'm down at negative 10. So this is why people don't like this rule. You got to remember, two negatives cancel when you're multiplying. When you're combining things, when you're not multiplying, you're combining them, two negatives stay negative. Because you're in debt to a lot of different people. You're still in debt. You can't make debt disappear by getting more debt. I've tried it.
So if you have a 2 in front of that negative 5 with the parentheses, that'd be negative 10. See on the second one?
Yeah, let me catch up to you. On this one?
Yeah.
If I had a 2 in between like this,
Or just a regular 2, let's say. Well, that would be
like this.
10 right there, right?
I'm with you.
That
I'm with
would
you.
be a positive 10.
So this is negative times negative is positive 5. This just says 2 times negative 5. And of course, 2 negative 5s is negative 10. I love it. That's actually another way of saying this situation. How many negative 5s do I have up here? 2 of them. So 2 negative 5s I already know is negative 10. This just says I owe $5 to 2 people. Right? Yes, sir.
When you just erased, you had the 5 times 5 times 5, then you had the negative 4, negative 4. So basically, those 3 negative 4s would just add up to negative 12.
No, you gotta be careful. So this problem here. So this was 5 squared, right?
Right.
And this, of course, was negative 4 cubed.
Right.
So let's just focus on negative 4 cubed. Negative 4 cubed is not the same thing as negative 4 times 3. That is negative 12. You with me?
Yeah, so far.
But I know, in fact, we know what this represents. It represents this. And are those things adding up? What operation is in between these things? Careful. So I have a negative 4 sitting right next to another negative 4. What's in between here? Anything in between there? There's nothing in between there, right? There's no symbol. So that means multiplication.
All right.
So this is getting a little ahead of us, but you all should have seen something like this possibly somewhere in your history. Mm-hmm. We know that represents multiplication just because they are sitting next to each other. This is 2 times something. I don't know yet. Nobody's told me. Nobody told me what x is. So if I want to subtract them, I'd actually have to put a subtraction symbol in the middle. So anything sitting right next to something else like this means multiplication. If I mean something else, I got to put this symbol in the middle. Is that cool?
Yeah.
So if I wanted to get negative 12, I'd have to write it like this. Now there are subtraction signs in the middle, right? But this is a negative 4 sitting right next to a negative 4, sitting right next to another negative 4. That means multiplication.
Okay.
The only reason I have to use parentheses is because that negative sign, I want to keep it separate.
don't the parentheses also mean multiply?
Exactly. That's why I want to use that notation here. I don't want to just use a dot.
Right, but I'm saying either there's nothing like the 2x or there's a parentheses that they.
Yes, good. I love it. Beautiful.
Now, if you ask us to solve that problem, it would be 64, right? If
Yeah,
you want-
you gotta be careful. Negative 4 times negative 4 is, careful. 2 negatives do what when you multiply? So this would be positive 16. Is that cool? Times negative 4,
So it'd be negative 60.
negative 64. And the really cool thing is, if you have a big old string of multiplications, if you have an odd number of negatives, now watch. I gotta be careful not to flick you guys off. So I have 3 negatives. 2 of them will cancel. Any 2 negatives will also, let me do this one. Any 2 negatives will always cancel, so there's 1 negative left. So if I have an odd number of negatives, when I multiply it out, it's going to end up negative. Because 1 negative is going to stay alive. These 2 die, these 2 die. This dude's left alive. So if I had a string like negative 1 times negative 2 times negative 1, like that, I already know that it's going to be 1, 2, 3, 4, 5. It's going to be negative. Because these 2 negatives cancel. These 2 negatives cancel. He's left alive. Right? So then I can say that's negative 1 times 2 times 1 times 1 times 2. 4. So it's a really cool shortcut. Just because any 2 negatives in a multiplication problem will always cancel. So if I have an even number of negatives, 1, 2, 3, 4 negatives, these cancel, there's no negative left. So this answer is going to be positive 4 in this case, right? How we go? So it's a really cool shortcut based off of that, what we talked about earlier. Negative means the opposite of. Well, these 2 opposites cancel each other. These 2 opposites cancel each other, but there's 1 left. Nobody canceled this dude. Right? Okay, cool. Maybe. Okay.